So next we're going to look at the actual demonstration of the KeyValue store as we have it running here at the Supercomputing conference. And so first of all, I want to show the Ethernet switch, the KeyValue store, and then we'll show the dashboard, the SINET connection, and the drone that's feeding data into the KeyValue store, both from the wireless link and from the data acquisition system that has the wired link. So this is the system. First of all, we have the FPGA card itself. And so the FPGA card, in this case, is a Nallatech P385. It has standard SFP Plus or QSFP Plus Ethernet ports on it. These Ethernet ports go directly into the FPGA. And so the FPGA has memory attached to it. And so directly adjacent to the FPGA are DDR3 memories that allow the FPGA to do a read and get the result back without leaving the card. And so our KeyValue store is effectively taking an Ethernet packet in, performing the KeyValue lookup on the FPGA, and writing the result back out, all in hardware, all on the FPGA card. So our entire KeyValue store operates on this card. It also operates on this card. This is a P385, the Stratix 5 device, at SFP plus 10 gigabit Ethernet. It also operates on other vendor cards, a PLDA card with multiple QSFP ports and different configuration of memory. And so we've ported our KeyValue store to run on multiple off-the-shelf FPGA cards, and we can run this database on different hardware platforms. So this is the topology of the system. So this is a Ethernet switch. So this is a 10 gigabit Ethernet switch. We have the fiber coming in from SINET. So this is single mode fiber that comes in. We have multi-mode fiber that's connecting our FPGA card to the switch. We also have the wireless data coming in from the wireless base station, and we have the wired data, sensor data coming in from our Black Diamond system over this Ethernet connection. So data coming in wireless from the base station, wired from the Black Diamond, being switched by the Ethernet switch, going to the KeyValue store, and then also available in the wide area network through SINET. So the KeyValue store system itself, the FPGA card is inside of the server, just as a standard PCI Express card. And the PC is being used to run a dashboard. And so the dashboard is displaying the live data as it is being received, or as it's stored on the FPGA card. And this software client is just simply a dashboard to show us the value of the data. So I want to do a demonstration now of the KeyValue store monitoring the operation of the drone. So we're going to start by having the drone take off. And we're going to have the drone be flying up. And so at this point now, the drone is in a safety cage, so it doesn't fly out and injure anyone at the conference. But it's maintaining level flight. And the sensors are giving us data that shows us how the horizontally the movement is changing and how vertically the movement is changing. And so if I take the drone, if I land the drone, we'll see that we see a vertical spike in vibration as the drone landed and bounced off the platform. And so in general, that these sensors are monitoring the data from the drone. So we can also do analytics in the live streaming data. So whereas these are the 6 primary inputs that are being plotted, is that we can also have these 2 graphs that are showing an output that is a weighted function of multiple primary inputs. So as these live primary data inputs change, is that this weighted output function can show us a metric that is either machine learned or human programmed characterization of the goodness of that. And so we have 2 different opposing functions that are being plotted in these 2 charts that are a function not only of the drone's position, but other external inputs. So for example, we have a strain sensor, and as the strain sensor force is exerted on it, that these functions are a function of that as well. And so that you can see the inverse correlation between the force and this function. You can also see how this function is taking primary inputs and producing a weighted function at the output here. So another interesting question comes up is, how well does this scale? Is that here we just have one drone that's flying. what if we had more? What if we had thousands? So obviously we don't have room in a booth for 10,000 drones, or even room in this convention center for 10,000 drones. But we do have a script that can simulate the network traffic as if there were 10,000 drones. So let me go ahead and run that script. So I just started a test that's equivalent to traffic being sent from 10,000 drones. As you can see that even with that added traffic load on the system, that we're still able to maintain live data streaming and keep up, because this FPGA KeyValue store can handle the offered load from tens of thousands of drones and handle the data that's being generated in real time and keep up with that data because it's been offloaded to the FPGA hardware. And so even with that extra traffic that was being thrown into the network from our simulator, is that the system is still able to keep up and still able to operate just as well with 10,000 drones as it was with one.